Hello again, YouTube. Welcome back to another Adventures in Coding video. Today we're going to be continuing along with our particle shaders we've been working on. First off, I want to start by sorry for the slow amount of time since the last one. I've been super overwhelmed with work and trying to make progress on the game. I think I'm just one of those people who's not very good at jumping from project to project. So I've been working on the game. I'm about a quarter of the way done the next chapter of the game, chapter 3 of 4, which is very exciting. I'm finally closing on the end. But that's kind of been what I've been working on and what's been slowing me down on this. As we also get into this, I've hit some issues with this project, which kind of burned me out for a while. I needed some time to recoup. But here I am. I'm ready to go again. We're back with our particle shader. So, with all that being said, in today's video, we're going to cover some new ground for the particle shader. The first thing we're going to do is we're going to switch our shader to use bindless textures rather than our array of sampler 2Ds, or our array of sampler, I should say. We're going to create a particle emitter class, so instead of doing this not exciting create particle function, we're going to create emitters, which is going to be giving us better and better results, closer to what you would want to see in a video game. And along the way, we're going to kind of just improve our project and our code setup. So I've kind of been mentioning it throughout, doing a little bit of cleanup, a little here and there. We'll keep doing that as we go. This is going to be a good one. I think this is a big step for us, big improvement. It's going to be a lot of typing, we'll see, especially with particle emitters. There's a lot of variables just to hold on to. So, with all that said, let's get into it. And we're going to start by talking about bindless textures. So, you might be wondering, hey John, why are we talking about bindless textures? Why are we worried about bindless textures? Where we left off with our last video, we had our particle shader, we had a bunch of different particles, we were supporting different textures and colors. This was all good. I kind of got started with this and I started running on emitters and I was making some good progress. And I saw these kind of artifacts in our result and I figured, oh, I must be doing something weird. I'll clean that up as I go. So I worked on it for a couple hours and then I said, you know what? I need to figure out what's going on here. What is this? So I wonder, I have a video here of it I recorded. I got pretty in the weeds trying to figure out what was going on here. I feel like maybe our normal output is a little better, but what you see is in the image, there's these weird artifacts here. And I couldn't for the life of me figure out what was going on. I went through, I tore out every bit of code in this project. I replaced everything. I tried writing different code in the shaders. I tried all of our classes changing things. I got rid of indices. I got rid of everything. I even tried updating my graphics card drivers. I came pretty close to swapping out my GPU to see what was going on because I just couldn't figure out what was happening. So after burning a lot of time on that, I eventually kind of figured out what was going wrong here. And as I started narrowing down closer and closer and closer what the problem was, I began to realize that it was with our samplers in our shader. So you can see I have an array of textures with these sampler 2Ds, which I sample. I hadn't actually used this type of approach of an array of sampler 2Ds before, but I figured it made sense. It'll work for us. If you guys remember from the text rendering video, I actually used a sampler 2D array, which I'll show you in a second. I've got the code up we can take a look at, but a little bit different. In that case, it's a 3D array where it's all of the textures are loaded into one object, whereas here we have all of the textures which we bind to different indices. But as I started investigating this, what I was finding was every time I would change the texture I'm drawing on screen, I would then get artifacts on the next texture. So for instance, if I drew a smiley face first, and that order is always kind of random, right? The smiley face would come through no problem. Then if I switch to this box, the box would have issues. Then if I keep drawing the box, no problems, but if I switch back to the smiley face, it would have issues. And so I began to realize that there was something weird going on with this. And even down to the crazy thing with this code is if you write hard code in here every single time I'm going to sample texture at index 0 and texture at index 1. I know this is not actually good code, but if you were to do this, store the results and not actually use it, it would work fine. So the reason for this issue, as it turns out, is OpenGL does not like variability when it comes to sampler 2D arrays, where in one pass we use a certain texture, and the next pass we use a different texture. So that was a huge investment of time for me to get to the bottom of this, but it was kind of interesting to find out the answer to that. So we're going to have to make some changes. I wanted to kind of review before we jump into bindless textures why I'm doing this. So obviously right now we are using an array of sampler 2Ds. Just to kind of go through this, you might think to yourself, well, we've used single textures before in the past. What's wrong with that? The reason why I don't want to do that, right, is because we're going to have all of these particles and we want to be able to render them all, as many as possible, in one call. We would have to make a bunch of different variables like this, or a bunch of different samplers, which this does happen sometimes, especially in 3D rendering. You could have like your diffuse, your albedo rather. You can have your roughness, you can have your metallic, your normals, these different textures, and you could render them all for one object. But because we want to render multiple objects, it's going to make the code very difficult to make work, and it's going to have a lot of clunkiness. So that's why we want it all in an array. So we've tried the array, that didn't work out well. With the texture video, we've done a sampler 2D array before, and that worked out really well, right? We were able to get all of our text rendering on screen. So you might ask, why don't I want to use a sampler 2D array? The reason for that is with a sampler 2D array, we have to set the size of every texture in the array. So you get into this ugly situation where you don't want to make it too small, because if you have some textures that are higher resolution, they have to be scaled down. But you don't want to make it too large, because if the majority of your texture resolutions are below that, now you're just wasting space. Because if you have to scale a texture up, you're just duplicating the same texture, the same values over and over again, and you're going to lose space in memory as a result and get no benefit from that. So that's why I'm not a huge fan of using them. At one point in time, I had them in Redeemart and in my engine, but I ended up switching away because of this. Now, that being said, since that time, that was quite a few years ago, I've learned about sparse textures with OpenGL. Now, both bindless textures and sparse textures are extensions. This is kind of the unfortunate thing about OpenGL development where it's at right now, because it's kind of left where it is with version 4.6. There's no more versions coming. Vulkan is what you should be moving on to if you want the latest and greatest. OpenGL for many years had this approach of extensions, where people could make extensions, they could add new functionality, and if they were popular and if they were good and everybody agreed, they would bring them into the language and bring them into the standard. So that was really great while they were putting out new releases, but because they aren't doing that anymore, we have this awkward situation with OpenGL where honestly, if you're going to use OpenGL, you end up using extensions, which opens the door to somebody's computer might not support these extensions. Now, that being said, pretty well all graphics cards made in the last 10 years support most extensions you would want to use, like sparse textures or bindless textures. Okay, so that's kind of the spiel on extensions, but that's also part of the reason why up until this point I've avoided using them, is because of this. And to be honest with you, I don't love that my game uses spineless textures, just because, you know, it kind of keeps you up at night thinking, is this going to work? So sparse textures, just to kind of give you a brief overview, we're not going to do anything with them. I'm not even going to go too in depth here. I just wanted to kind of give the caveat that if you did want to use a sampler 2D array, sparse textures actually give you a way that you can set the size of all of your textures to be quite large, but you can actually not load your textures to that size. So sparse textures let you kind of do two things to the best of my understanding, and this is to the best of my understanding because I haven't used them before, but they let you promise you're going to load a texture to a certain size and not actually do it until you'd like to do it later, which is nice. And they also let you break down a texture into smaller pieces. And so if you think about like an open world game where you have a big land mass that all has one big texture, sparse textures would be a great choice there, where you can just load into memory the blocks or the quadrants of that texture around you, the grass that's nearby. And as you move around the map, you can deallocate the sections that you're not near, that aren't in view, and allocate ones that will soon be in view. So even without using those kind of blocks, what you can do is you could use them in conjunction with a sampler 2D array. So you could set the size of your sampler 2D array to be really big. It's going to hold 4K textures, but every time you load a texture that isn't as big as a 4K texture, you just make that promise that you're going to, but you don't actually do it. So those are kind of my spiel on the other options. What we're going to do today, which is what I use in my engine, is we're going to use bindless textures. So the benefit of bindless textures is previously when we would load textures, we would give it to OpenGL, we would tell them to make a texture 2D, they would give us a GL unsigned int back, which is kind of our handle, and we would bind that every time we wanted to use it. With bindless textures, we take that GL unsigned int and we use some of the bindless texture code to make a handle from it, which will give us a 64-bit unsigned int. And with that value, we can just give that directly to our shader and we can use that for textures. And so the benefit of this is we're going to be able to have that kind of array approach that I wanted with our example previously without the artifacts. And it also makes it easy and nice in that these textures can be different sizes. They can change. You can have new textures. You can move your array around. You don't have to worry about binding. And you can just use them all in the shader. Okay. So I think that that's most of the talking. Sorry for the long spiel. One last thing I'll mention just as we get going in here is depending on if you are using Learn OpenGL, for these projects, they rely upon GLAD. Where is it? Here we go. And so with GLAD, depending on your installation, your version, you might not actually have these extensions set up. So this website, I know it looks like super random, GLAD David DE. This is kind of the go-to if you want to make sure you have all those extensions. You could do the newest version of OpenGL. We're going to end up bumping up to 4.6, I think. This is one of the things I also had reservations about. I like to maintain the compatibility, but here we are. And you can go through and you can pick the individual extensions you want. You could get just the bindless textures in here. You go, ERB. NV here is NVIDIA. NVIDIA initially did this, and then ARB is kind of the more generic version that works everywhere. Or you could just grab them all. Once you do that, you can hit generate, super quick, gives you these files, and if you click the zip, you'll download that. You can see I've done this a couple times. Inside those, there's a source folder which has glad.c, and there's an include folder which has this KHR and this glad. If you want to upgrade the files that are in your OpenGL, Learn OpenGL, all you have to do is in the source folder, there's that glad C, and the includes, here's the H, and here's that KHR. Okay. So you can just swap those out, just in case anyone, like me, I think I must have grabbed this repo a long time ago. I don't know what if the repo has this normally set up, but I ended up having to do this. Okay, so with all of that yapping down, let's start to actually write some code. So we're going to do a couple things. First off, we need to start loading our textures and making sure that we have those 64-bit handles and the proper setup to use them. We want to make sure that whenever we load a texture, that happens. Actually, you know what? Before we even start talking through everything, let's just start writing some code. Okay, too much talk. So right now we have our function here, this load texture. Obviously, right now it's returning an unsigned int. This is the same as a GLU int. I'm trying to think of like a good way to say that, uint. But it's the same thing in essence. We're going to swap this over and we are going to set it up to return a GL 64. Okay. So this is going to be a little messy. We're going to break some stuff doing this, but we'll start making the change. All right. So we can keep most of what we have here because this is we're still loading a texture just like we have been before. Oops, gotta get rid of the unsigned too. That's all good. We can keep all that. I might even swap this to be a. Do I not have it included? All right, we can leave this out. So we'll keep all of that. Really, just after we have the texture loaded, we have to make sure that we call our function, which is going to ensure that we have that handle. Let me just make sure I have. There we go. My example. Okay. So same deal here. We load our texture. We end up creating it, and we return it. Right. So we have this texture. We're generating, we bind it, we set it up, we use stbi to do our loading. That gives us this raw data. We then pass that to generate our texture, we free that data, and we return it. Okay, so that's all pretty hunky-dory. Oh, we also generate a map if we need it. And so what we're going to do here is I'm going to move this down. So this all only happens if data is good, so if we've properly loaded. Pretty easy actually to do this. I found I had to use, way back when I did this, I had to use that OpenGL paper, the NVIDIA paper to write this, which was not the best. It's not really like the easiest to make heads or tails of, and it's all plain text, which kind of sucks, but it is actually not too bad to do this, make this change. So we're going to make this a resident, which means it'll reside in our GPU. And if you want to deallocate it, you'll have to make it a non-resident. That's something that at some point would definitely be a good thing to add. And then we'll return that handle. Okay, that looks good. All right, so now we are loading our textures and making sure that they're ready to go as bindless. That's great. Something we're going to do next, which isn't going to directly change our results, but is going to be kind of along the path of making this code better and better, this project better. Right now, in our particle system, we store all of our textures, all of our texture map to make sure that we don't reload the same texture. This is all embedded in the particle system, and that's not great. Obviously, we're just making a particle system here, but we want to think about this kind of fitting into the greater scheme of a project. And so I'm going to add a new class. I'm going to make a new class, which is just going to be about loading textures. Like I said, this isn't going to give us any new benefits, really. It's just from a design perspective, a good idea to have. And a fair amount of this is actually just going to be copied. So, for instance, we are going to hold on to some textures, and we are going to have a texture map. Okay. Oh, private. We're no longer going to be Assign int. These guys. We need to add some includes. Include. What do we got? Vector. Excuse me. Include map. We're going to have to use that helper loader. You could really put that in here if you wanted. And we're also going to include string because we're going to use that for paths. Okay, so just like before, this is going to hold all of our texture handles. This time they're just that 64 format. This map is just going to try to, if we already have a texture loaded, if that string has already been loaded, we're going to try and use that map to avoid duplicates reloading. Okay, so I'm going to add some accessors, seeing as I have committed to some good clean code of proper private and public. Textures, turn and textures. Oh, right, these guys should be static. That's something else to talk about. So by making this project, or this class, I should say, static, that means you don't actually need an instance of it. So you don't have to, at the start of the project, create a new texture loader because it is a static, most of its members are static. That means that you're going to be able to use this anywhere as long as you include it. And it's not going to have data stored in an individual object. You can't have two texture loaders. And if I wanted to, I could, this is kind of like a singleton class. If I wanted to, I could enforce that, but I'm not going to do that. The reason why I like to do this is it means anytime we load our textures, we can use this class and we'll always benefit from the map. We'll always benefit from not loading the same textures over and over again. And it's super convenient to just include. There would definitely be, you know, try to be pretty easygoing when it comes to designs. I could definitely hear an argument of somebody wanting to not have it be static. Definitely some merit to that, but this is how I like it. Okay. So we'll call load texture here. And our load texture is really just going to be kind of duplicating what we did in our particle system. So in our particle system, where was that code? Whenever we would create a particle, we would check to see if we have that texture in our map. Otherwise, we would call helper load texture, right? So we're going to do something very similar. I'm going to move these. Okay, so it looks like I changed the name. So if we found it, we will return textures at. You don't have to use at. You can also use the heart brackets. At is a const operation, which is nice, but it really doesn't factor in here. Okay, so if we do load it, we place that back, which is good. We're going to insert, and we will return texture. And if we have some issues, we'll just return -1. Okay, so that's really great. We're making progress here. Oh, I need to return. As I say, it's really great. We also need to, because these are static members, these guys here, OpenGL, C++'s static syntax is a little weird. Because they are static, you need to, in the CPP, define them. So, and it's especially weird because we get rid of the static in front, but these are the things you just get used to, you learn to live with. Okay. That looks good. So now we have our texture loader. We're going to utilize that anytime we go to load textures. And of course, continuing along with that, that means in our particle system, we're going to do a bit of a, I don't know, I was going to say like a butchering, but not even that extreme. We're going to update this. We're going to make some changes to all this. Okay, so we still want to keep this instance order to texture. This we're still using when we render. I'm going to keep textures in here for the time being. These are just going to be, I know this looks like duplicated data. Here, our textures are all of the texture handles that we load for this whole project. In this case, these are all of the textures that we're using for our particle system. Okay. And the other thing I'm going to have here is a texture handle map. So if you have a given handle, it'll map it to a location in our textures. Now, I think I said this earlier, but I'll say it again because this is probably a good time to mention it for once more. When I worked on this, I started out by adding emitters and then hit all of these issues with having problems with the bindless textures. And so I did this in a different order. So it might get a little funky, but I think we can still make it work. Okay, so to go along with this, I'm going to add a function, add textures. Now, I'm making this private because this should not be called outside of this class. Whenever this is called, very similar, we're going to look to see, does that texture already exist in our texture handle map? If it does, then we'll add it to our instance order. If it doesn't, we will add it. We will insert and we'll add it to that instance order. Does not want me to be able to type at. Okay, in spite of IntelliSense trying to kill me, we got that. Now, whenever we create a particle, instead of writing this code over and over again, we will just say add texture. Actually, wait a minute, let me make sure I'm on the right path. So this is where my two examples have diverged with what we're doing and what I did. Okay. We might have to adjust this later on, but for now, we're going to say add texture, and we're going to use that texture loader. Texture, and we'll give it that image path. I think we can actually swap that. Inaccessible. me talking too much. There we go. You'll notice VS Assist here shades this a little bit. You'll see this often. It doesn't like having these if-elses where you don't necessarily need it. So like here, once it analyzes it, it'll do the same here because it'll say, oh, well, you do this if check. Otherwise, you're always going to run that. So, okay. Now, our bind textures has changed a bit. It's no longer the same, really. And the reason for that is before we were binding these unsigned ints, right? We need to update that. Okay. So we've updated the way we load textures. We've added in our texture loader class, which is going to help us. I know it seems like a sidestep, but if we want to grow this project, that's good to have. We've updated our particle system by adding that add texture. The one final thing I would like to do is I would like to add to our particle class that actual texture handle. This is one of those things where right now we're not going to use this. I don't even know if we'll set it. Maybe down the line. For now, we won't even worry about it. But I'm adding that in there because later on, I would like to have more of our texture or our particle data being sent to the GPU rather than having to maintain these arrays, right? Like right now, I have to maintain textures. I have to maintain the instance order to texture. It's a bit of a pain. So at some point, we're going to start to change that. Okay, so now the next step is we need to update our shaders. So we're going to do a couple things. First off, I've been saying we're going to do this for a while. We're going to bring all of the shader code into our particle system. So these guys, the VBO, the VAO, the EBO, our shader, all of it is going to come over. As well, we are going to make a shader storage buffer, which is going to be used with our bindless textures. Okay. So I'm going to rename all of these. Shader. This is probably just making more work for myself, seeing as I'm going to have to rewrite some code as a result of this. We have those guys. And the last thing I'm going to add here, I should really switch all these to the okay, is a handle to that shader storage buffer, which we're going to take a look at as we go along here. All right. Now, a fair amount of this we're going to be able to copy over from what we had. To go with it, though, we got to make sure we have a initialize function, which is going to handle all this. Initialize. I'm going to add a cleanup in here. If you've been paying attention, I have not been cleaning up particularly well when we shut down. Thus far, I've just been like, well, we're shutting down. Not my problem anymore, right? But that is not a good habit to be in. So I'll just copy what we have in main, but there is other stuff we should be deallocating. So where's our cleanup? Cleanup here. Right now, we just delete all of these guys. I'm going to cut that. Paste that over. We'll add some M underscores. Okay. Good. So here, I think our particle system is called PS. Cleanup. Okay, now we're going to steal a bunch of this code here. So we definitely want our shader. We want all the vertices all the way to there. Get that comment too. I don't really like the learn OpenGL comments that much. Not that they're bad, but just not the level of granularity I would use. I'm going to leave that as that right now, but I should really be checking that. So in our initialize now, we say shader. For that, I think we're going to have to add an include. OpenGL shader. Yes. Okay, nice. Vertices. We'll add some M's. Okay, that looks good. We are going to add in a check here. Are we? Maybe we won't. All right, I'm just going to return true. Really in here, I should be checking to make sure everything works out well. Otherwise, we would return a bad value. We'd return false if there are any issues. And then back in main, when we call this, we'll say if is false, return false. Because this guy's also returning. I should really say return true at the end of this to be clean. And yeah, it looks pretty good. Okay. Now you'll see our shader here. It's not too pleased that our shader doesn't exist anymore, right? So I'm going to pull that out. Call render here. Projection. Now back here, we no longer need to accept the shader handle because we have it inside our class. So this is going to change, and we'll also be able to use this. So we don't need that line anymore. We'll swap these guys. Except we need .id. Okay. I think that looks pretty good. Let me just do a pass and make sure I have the order right. I know I still have that error around the textures. Okay. Shader, we bind it. This looks good. All right, so now we need to make that pesky SSBO. It's actually not too bad to do it when you know what you're doing. The code is actually not that difficult. It's just, it can be very overwhelming trying to find good resources online. The thing, of course, I will call out right now is we are doing this and we've made an awful lot of changes already. So always rolling the dice whenever you have a bunch of changes you've been making and then you try to add in some new code. So it's already all broken and then we're going to rely on having this working. We'll see what happens. So we're going to generate that buffer, the memory address. Okay, so we're going to bind buffer. It is a GL shader storage buffer. Okay, so this probably not too crazy. You've seen this pattern a lot, right? We generate a buffer and then we bind it, right? Here, we're going to say buffer data. Whoops. Okay, once again, we need that GL shader storage buffer. Now, this is where we're going to set the size of the data. So right now, I'm going to just say 100 times size of GL4. This is where we give it the initial data. Because at the start we don't have any textures loaded, I'm giving it a null pointer. and then I'm saying GL dynamic draw, because we are going to be changing this. And after that, we will bind 0. Okay, so what did we accomplish with this? We've now created a buffer on the GPU, which is going to hold 100 unsigned int 64s. So we've just allocated that space on the GPU. Otherwise, we haven't really done too much. Okay. The next step, we're going to say GL bind buffer range. It's again still shader storage buffer. Now, we have this index here. This is going to look like not a big deal because I'm just going to put a 0 here. But when we go to set up the code, if you go to make more SSBOs, this is the index of this SSBO. This matters. We're going to use in our shader. We're going to specify it explicitly. It is important. I'm just putting a 0 here so it looks like, oh, it doesn't matter, but that's what that is. So we give it our buffer. Our offset is 0. Our size is going to be 100 times. Okay, so this is going to be what ties it to our shader, which is very helpful. I'm going to put the VAO stuff underneath. Okay. Now, here's the cool stuff. So before, we were just calling bind textures, and in here we were doing that loop, looping through them all, binding them. We're going to scrap that. First off, I'm going to check to see if textures.empty is false. We don't really want to necessarily do this if that's already empty, right? It's not necessary. It's already empty. So we'll bind our buffer. Then we're going to call GL buffer sub data shader storage buffer. Okay, our offset is 0. Our size is going to be, I'm doing int here. Really probably shouldn't even be doing that, but all right, and textures at 0, and we need reference. Okay, after that, we will then nothing, and that's it. I'm also going to put that in here. So what does this code do? So we bind the buffer we're talking about. Now, the really cool thing here is this line has attached our buffer to index 0, and that's it. Here, we're not doing anything about telling the shader about the buffer, right? Normally we do this get uniform location and we change the value. Instead, we are just messing with what's stored in that buffer. So we bind it. We do buffer subdata here. If you're wondering why it's subdata, it's because we don't have to do all of the data on the buffer. And in fact, this offset we have set to 0. That means we're always going to start at the beginning of the buffer and do a variable length update. You could offset. If you just wanted to update one texture, you could do that, and it'll be more efficient as a result. All right. I think that looks pretty good. Let's do a little perusing, see if I've broken anything. Doesn't look like it. Okay, so now we need to start working on our shader. I know this has been a lot of code. We've gone through quite a bit of time of writing code here, but we're almost done. So I'll just remind you, if you're following along and you want to use this, you might have to update GLAD. I'm going to, right here and now, upgrade our version number to 4.6, the most recent. Okay. And now we're going to switch over to our shaders. So first off, we're going to upgrade our shader, boom, just like that, to 4.6. I'm going to increase the upper limit of how many matrices we can have here. Is there any other changes I made? Not really. So our vertex shader, not much is changing. I'm just allowing more matrices. Something else I'll kind of note here, we're kind of opening up this Pandora's box of SSBOs. I typically avoid doing stuff like this in the videos just because it adds complexity. I like to really focus on kind of the theory or the mechanism we're working on, where SSBOs and UBOs and these types of things, sometimes you just end up kind of in the trenches of OpenGL instead. But by starting down this path, we can move away from these hard set array sizes, which means we're going to be a lot more variable and we don't have to deal with these limits, right? Okay. So over in our fragment shader, we're going to do 4.6 and we need extensions. GLRB, Bindless, texture, require. I've seen enable and I've seen require. I think both will work. I like to use, I'm just using require here because it sounds more intense. B, GPU, shader 5. Now, my best understanding of this GPU shader 5 is this was around what we talked about earlier with shaders or with samplers using different indices, different results per individual quad. This is around that, I guess. I don't know too much about this, but I know that typically anytime you use bindless textures, you also want to have this extension. Okay. So we are going to declare that SSBO. I actually hadn't done this in a very long time, and I, for some reason, thought I didn't have any SSBOs in the game. Because of that, I thought I only had UBOs. UBOs, uniform buffer objects, behave similarly, but they can't be as variable length. So our binding 0 here, I'm going to call this out one more time, means over in our setup, this 0, which one is it? This 0, our index is mapping to this binding. Okay, and this STD430, that has to do with how the data is stored, how it's compressed, not even compressed, how it's aligned, I should say. And name it texture handle block. And we're going to have a assign to texture handles. No array size, very, very handy. And we're going to have to update this. I might do this just above so we can compare and contrast. So we're going to call the texture function. Have to cast to a sampler 2D. Give it texture handles at our instance order to texture x. Our coords. Okay, and then times our color. Okay, so this doesn't look too far off, right? A couple differences. We're using texture instead of texture 2D. We're casting this unsigned vector 2 to a sampler 2D, which is very interesting. And this just has to do with storage, where we have those 64-bit values, which we're holding in here, and then we're going to do our cast, which is going to convert it to our sampler. And I guess while we're at it, let's bump these all up to 200, and we'll remove our other textures. But otherwise, it's very similar. Okay. The other thing I'm going to add in here while I'm looking at this, frag color.rgb. So if we have an opacity of 0, discard, or if we have a color of 0, I guess maybe we don't even want that. We want to support the color black. That's a bad idea. Never mind. Okay, this looks pretty good. This is going to be a bit of a scary run. We're going to see if everything works out okay. We have some errors. That's okay. Deep breath, everyone. So in our particle, we don't have that defined. That's okay. Have to add in. Glad that's a little silly because I added that and we're not even using it. Okay. Is that it? How do our shaders look? Those are the real question. Come on. Whenever I run this as release, I find it takes a long time. Okay, nothing on screen. No errors. I'm going to switch to debug. I just want to make sure everything around those textures is okay, because I did make that change for this video. Okay, so let's take a look. We have two textures, that's good. We have our instance orders, that's good. Some matrices, that looks good. Some texture, here's some colors. That all looks good. Okay, while we're doing this, I think I've done this in a couple of videos before, but I always like to, just off the bat, if I return pure white, do we get? No, we do not. Interesting. Okay, so we got something going wrong. Let's make sure our paths are correct. Looks good. I wonder even, it wouldn't be this. We swap this. Somehow I managed to do this whole example beforehand and just stayed at 3.3 here, which is kind of weird because it then uses a 4.6, but okay, so what are we doing wrong? Let's try switching back down to 100. That shouldn't really be it, but. And then I want to make sure in our render I'm doing things properly. So we use our shader. We should make sure it's all set up properly. It looks like it is. Let's make sure we call. Okay, it has an ID. That's a good sign. Something that's a good idea here, just to see if anything is going wrong with OpenGL, if I'm doing anything wrong. I'm going to add this in. I use these all the time, all over the place in my engine of just, this will tell us if there's any errors. We'll throw. No errors. Okay. Well, while we're at it, let's comment these guys out. that. So what's interesting is we're not getting even the white triangles or the white quads on screen, right? Which I find very interesting, because I would have thought that we would have the vertices coming through, but an issue. Well, I wonder, is there any more code? No, that looks good. Send it to view projection, we swap. That looks all right. Let's try adding this guy in here. Okay. Do we throw there? Starting to feel like this is a dumb issue. No error still. Okay, so we map. We create all of our buffers still, right? I don't think I changed anything over here. This looks good. We have some matrices, which is good. Do we bind the VAO? Because if not, that would definitely do it. Where the heck is that in my other code? Let's see. Is this the juice we need? Nope. Thought maybe. I wonder where that is in my other code, though. Just make sure none of this is the problem. We don't have any errors coming through in the shader, which is interesting. Oh, there we go. Okay. So we are getting through. That is great news. Now I'm assuming we're having issues with our actual texture. Interesting, no errors, but okay, so let's make sure all this code adds up. I wonder if I just return 0, how does that look? Nothing. Okay. I wonder if we try using index 1. Do a little read through and make sure none of this is wrong. Okay. We generate it. We bind it. Switch off. Let's try using binding 1 just because that's what I actually used. And then nothing. I wonder when we load our textures, is everything working okay here? Looks good. That looks good. Oh. Wait a minute, wait a minute. No, 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 no. You need to catch that the right size. Come on. I pray that's it. Suspense is killing me. There we go. Oh my god. It's always the stupidest mistakes. Okay, I was talking too much, so I was trying to store it. I think I copied that from what we had before. Now, switch that back. I'll bump these guys back to 200. 200. Okay. Nope. Didn't like that. Let's leave it as 100. What's going on? So if I do 0 here, we have an issue. Why would that be? It's weird because we literally were just fine. Make sure it's not color. No, not a fan of that. Oh, I know what the problem is. I'm flustered. I'm making too many mistakes. I switched my binding. There we go. Sorry about that. I switched the binding with those undos. Okay. Now let's try 200 again, just so we can maximize. Whew! Look at that. This would be why I was apprehensive of adding bindless textures originally. Okay. So we got our textures up and running. You can see no more artifacts. This is beautiful. Now, we've taken a long time to do that. We're going to knock out some emitters. So adding particle emitters, you're going to see is just a lot of typing more than anything. Not to be, I don't know, not to make it sound like it's not a very important thing, but so what we're going to do is we're going to upgrade our particle class to add some more data, specifically kind of some physics items, so like velocity, acceleration, orientation rate, scale rate, so that things can move over time, which is kind of what we want. So I start typing rather than talking, seeing as that seems to get me in the most trouble. Okay. As I'm typing, can't help myself but talk. So we talked about this a little bit as I was looking at the shaders, but starting to use SSBOs, this is kind of a good path to go down, and it would be nice if we could start to send these individual particles actually to the GPU. And that way we don't have to maintain that kind of ugly separate array. Okay, so we have a color here, which is going to be the current color we draw. I'm also going to add a start color and an end color, which will be what kind of adjusts the color over time. It'll transition over time. I'm also going to add a life float and a life span. Now, we're not going to do anything with those two really. I mean, we'll use it for our color transition, but we're not going to do too much with it right now. But just for the time being, we'll put those in. At a later date, we're going to start to put that in and actually start to deal with the dynamic memory of having particles die, wanting to get back that space on the GPU, and so on. So we have our update function. Update is now going to change because we're always going to be adjusting, looking to see if we can adjust these parameters. So if velocity changes, or if our velocity is non-zero, then our position is going to change, and then we're going to need to recreate our matrices, right? So I'm going to make a separate function, update matrix. Update looks good. What else do we need in here? We leave get color, get orientation, get position. I'm going to add in, I don't even know if we use it yet, but get texture. Turn texture. Okay, so now in here, the reason why we're doing this is we're going to update what we're doing in update. So if acceleration does not equal 0, then velocity plus equals. Hopefully you have a bit of experience with some high school physics. If not, there is plenty of great resources online. This probably isn't the venue. We've got a lot going on to actually discuss this stuff, but some things I'll point out. Like always, we always use delta time here because we want to be frame rate independent. And so our velocity is going to affect, our acceleration is going to affect our velocity over time. Our velocity over time is going to affect our position. Whenever the position changes, we're going to say transform changed. We're going to scoop this up and put it here. So update our matrix. Okay, now we're going to do the same thing with our orientation rate. So really, if we wanted to, we could just blindly multiply these and we could do the check afterwards, or we could just not do the check. I've created this paradigm and I feel like it's good to be consistent. Change equal to true if scale rate. So this is where I said there's going to be a lot of typing. 0 scale plus equals time and transform change is equal to true. Okay, so those will be all of the actual transforms. We're going to say life plus equals delta time. Here we would want to do a check based on the lifespan, right? But we're not going to. So I'm going to say if lifespan does not equal 0 and our start color does not equal our end color, we're going to do a lerp between them. So I'm going to get a normalized value, which is going to be our current life value divided by our lifespan. So if this particle's been alive for a second and the lifespan is 5 seconds, then this will be 0.2. We're 20% through its life. I'm just going to use this clamp, though, to make sure that we never go below 0 or above 1. And then we'll say our color is equal to the lerp between our start color and our end color with that normalized value. So this will smoothly move it from one to the other. Last thing we'll do is we're going to return update matrix, which in our handy dandy way of checking to see if transform change is true, we'll do that calculation and it'll return true to us. Okay. That looks great. Now, here comes the real typing. We are going to make our particle emitter class. So our particle emitter, it does have a fair amount of logic in it, and it's really going to grow over time. I don't have that much logic to start out, but what it has a lot of at the beginning is just data. So with particle emitters, you want to have randomness. You want to be able to make your particles seem lively. Like if every single particle you emit has the exact same velocity, it's going to look repetitive, right? So we're going to have fields to control how random or what direction it's headed in. So we're going to end up with a lot of duplicate data here. Not duplicate data, but just a lot of copy and pasting. So I'm going to add a class. I'm going to call it Particle Emitter. Okay. Set up a public. Set up a private. Okay. So here's what I mean. We're going to have a position. So this will represent where the emitter is in space. So for instance, if you have a gunshot, like sparks, a particle emitter for that, you have like bullet muzzle emitter, that'll be placed at the end of your gun, right? If you have a bloodshot effect, it'll be placed where a bullet hits an enemy. And pick it up, you know you want to. Or am I getting it from my other stuff? Let's get the rest of these. Helper, include particle, include texture loader. And we'll also add using namespace GLM. Okay, so this is the set position where this is going to take place. What we're also going to have is a vector2 position offset x. Now, what these guys are going to represent is that randomness. So we're going to have one set position. This is where our center of our particle emitter is. Then these three values will control how much randomness should be involved. If they're all set to 0, every particle is going to emit with this position. If x is set to -5 and 5, then it's going to emit somewhere along that range of 10 values. So this is my approach I go with. Some people, you might just want to float. You might want something different. I use these vector 2s because they let you have a minimum range and a maximum range. And we're going to update our helper to help us generate these a lot easier. And so we do this with everything. So we have our velocity. We have our acceleration. We'll have our orientation. We'll have our orientation rate. scale. And as I'm doing this, if you're thinking like, man, this feels like an overkill, in some ways it is. And really, I mean, we could use smaller data types. We don't need to be using floats here. Perhaps we could save some memory that way. But in the grand scheme of things, this really isn't going to take up that much memory. And we want to have that granularity of control. If you've used something like Unreal Engine or Unity, you are able to set all of these values however you'd like, right? I'm going to set scale to 1, actually. So this is going to let us have that control over all of our data. Start color R. So we can even have the randomness of red, green, and blue. Okay. Now we'll do end color. Okay. We'll have a lifespan. Our life is always going to start at 0, right? The lifespan, however, can change, and we'll have a vector 2. Lifespan offset. All right. Now I'm going to have a vector of textures. Now you might be thinking, boy, we have a lot of textures everywhere. The reason why I have these is I want to be able to have different textures. I want to be able to randomly generate which texture we're using. So I'm going to hold on to all of the handles here. Okay. So that's most of the actual data for actually spawning an individual particle. We also want how much time takes place between each emitting of a particle. And once again, well, let's start with this. I'm going to add in, and this is totally different people can have different approaches here. So my approach is going to be, we have this idea of an emit, which releases particles. And then we also have control of how many particles get emitted or how many particles get released per emit. Here. Offset 0. Okay. And then we're going to have a time elapsed, which is how much time has taken place since our last emit. And we're also going to have an enable. So this is kind of the interesting stuff. This project is growing. Usually with kind of code examples like this, you just have simple code where you just make one thing and that's it. Here we're going to be able to enable and disable. So I don't know if you can hear the truck backing up in the background. But okay, so I'm going to have a function to emit, which is going to spawn a particle. I'm going to have a function to update our particles that already exist. I'm going to have a function to do a one-time emit. So if you don't want to have it occur over time, you just want particles released all at once, you can do that. I'll have a function to enable. One to disable. I'll have one to toggle. I've got a name here, which in my code I had as public, seeing as we're being sticklers, I'm going to set that as private. Okay, that looks good. And now we need the constructor. Now with all of this code here, it's going to be a behemoth. So I am going to do a copy and paste. I always try my best to avoid it, but is it going to? There we go. Sorry. Why did that do that? Oh my god. All right, let's get these guys. And now I'm going to copy that behemoth. That's a lot of parameters. Okay. So what have we got in here? Now, inside our constructor, super straightforward. We're just going to set all of those. So like, we're going to say name is equal to name. Position is equal to position, right? As you might expect. I'm going to copy and paste that because, my God. Why does it not like that? Tell me I didn't forget a U. Oh, and I forgot offset. There we go. Okay. E on lifespan. So something else I have in here, a little tricky. I'm saying the time per emit is equal to 60 divided by. Coming in, I have the num emits per minute. So you really don't need to do this, but just I feel like it's a little bit easier to say I want to have 100 particles emitted per minute rather than like every 0.1 second do an emit. Okay, num offset. There we go. I think. Undefined. How could that be possible? That's weird. Oh. That's not good. That shouldn't be that. Ah, so I misnamed it. That's the issue. Okay. It's not the time per emit offset. It's the number of particles per emit offset. Sorry, we're getting caught up in the weeds here. The last thing I'm going to do, I will loop through the textures, adding them. Okay. So to do our emit now, we're going to take that position and we're going to take those offsets and we're going to generate a new position. To make this easier, I'm going to add a helper function in our help class. Static float calculate random offset const float starting. That's vector 2 offset. So this is pretty straightforward. I'm not really reinventing the wheel here. It's just going to take that starting value, generate a random number, and add it. But it'll make our code a heck of a lot cleaner doing it this way. Okay, so that's just for one float. Now we're going to do this for vector 2. And vector 3. And vector 4. Right, so the same approach, just this time we're doing it with vectors. Might do another copy and paste. So we just take that starting value and add to it the individual components randomly generated. All right, now to use this, super straightforward. Over in our emit function, I'm going to add that over here. When we go to emit, we're going to make use of these functions that we just wrote. So our position is going to be helper, calculate random offset, m position, then our position offset x, our position offset y, position offset z. Looks like I made a mistake in here. I need to starting gets changed as well. And these should also be by reference. Okay. So that's how we'll calculate all of these components. Once again, I'm going to do a little copy and paste. We are going long here. For all of those components, we're going to do that. So this will generate all of those values. Have our texture. If textures is not empty, texture will be equal to m textures at our helper function, generate random number, size t, 0, and textures dot size. So it'll randomly pick a texture. Now I do think we need to update our particles constructor because I don't think I have that texture field added, nor do we have all of the rest of these guys. So I'm going to do a copy and paste again. So this is just accepting all of those parameters. Really, we could probably go through and delete the old constructors because this is moving forward what we're going to expect, but for the time being, I'll leave them. So you can see we're growing in complexity big time. All right. So now with all of those values prepared and our constructor updated, we can return that. So I can do pose val orientation rate, scale rate, start color, and color. Life and texture. Of course, just like before, in a second here, vAssist is going to say, hey, you don't actually need to call a constructor. You can just do brace brackets like that. Okay, so that's our emit. We're making progress. For our update here, we're going to need some logic around our timing. So we're going to say if this emitter is enabled, then we're going to make a new vector. So this is going to hold on to any newly emitted particles. Now you might wonder, like, this is a bit costly, right? I'm making these vectors every time. Why are we doing this? That's because I want to try and loosely couple this to our particle system. You'll see that when we try to connect the two. So we'll add delta time to our time elapsed. I think we've done this before somewhere in our code. This comes up often in games, but I'm going to take our time elapsed, divide it by our time per emit, and cast that to an int. That's the number of emits. And we'll do time elapsed is equal to f mod f with time elapsed versus time per emit. And if number of emits is greater than 0, then we're going to do some emitting, right? And I'm going to generate int num particles per emit is equal to helper, calculate random offset, and from there, we're going to loop through int I number of times. We're going to do num emits times num particles per emit. Every time we will emplace back the result of an emit call. Okay. At the very end of this, we'll return that, or we'll return an empty. So once again, you might think, like, what if we just kept this big array, right, and we just emplaced directly into it? That would definitely be more efficient. The reason why I'm using these vectors like this is I like the idea that this particle emitter is not touching the particle system. It just emits particles, and those two aren't tightly coupled. As we move on, we're probably going to have to start to have closer interactions like that, but for the time being, it's nice to have them loosely coupled like this. So we're going to do something similar here for our one time, except in here, all we're going to do is, we don't need that. We'll say we will emit that number of particles, and then we'll return them. Now, the reason why we have this one-time emit function, obviously you can probably think of good examples. A bullet hits a wall and you want smoke to come up, or whatever. An explosion happens one time and you want to emit it. The other reason is we're moving away from creating particles inside our particle system. Our particle emitters are going to be doing most of the work. And so we want to provide that capability that if you just want to emit some particles easily, you can do so. All right, so that emitter looks good. Now we're going to make some changes to our particle system. So what do we got? We still have our texture data. I'm going to add in here 2 new members. We're going to have a vector of particle emitter. And we're going to have a map again. going to add that include. What do you think? Is it smart enough? Nice, it is. Okay, so now we need to add some more functionality around this. So these are going to be our vector of emitters. We can have multiple of them, and this is going to be our emitter map, which is going to reference them by their name. So we'll keep those, but we're going to get rid of our create particle. We're going to have a add emitter function, which is going to take a const particle emitter. We're going to have a one-time emit. So what this is going to do is it's going to take in the name of the particle emitter you would like to emit once, and the number of particles. Enable emitter. Okay, we're going to disable emitter, and we're going to toggle. Okay, that looks good. And I'm going to add a function to add a particle. This is kind of similar to the add textures. It's just going to make our life easier, add to particles. And it's going to take in that vector of particles. Let's get these guys all going. Okay, we're going to get rid of create particles. Sad to see you go. You've served us well up until this point. So when we add a particle, all we're going to do here is loop through the particles, and in our particles vector, we'll emplace back that particle. Okay, in our matrices, we'll place back one. In our colors, we'll place back. So all of these variables, or all these vectors we're keeping track of, once again, in the future, I'm thinking we try to bind everything to our particles, and we send our particles to the GPU to make things easier. What's wrong with this? I don't like that. And then we add texture. Oops. So we can swap this. vAssist is going to say you don't need indices. That looks good. Okay, and then so all of these functions, super easy. We could do a count check and be extra safe. We probably really should, but say emitter map at name, toggle enabled. So this is kind of getting into bigger software, right? We're no longer like just this vector of data. We now have the ability to access it by name, access a specific one you want. I don't know, maybe we will be careful here. So we'll add in our count check. Okay, and for our one-time omit, same idea. If we have them and they exist, we are going to call add particles, which is going to take a vector in, and we're going to do our emitters at our emitter map at name dot one time emit, and we'll give it the num particles. Nice and clean. And whenever we add an emitter, we say emitters dot in place back emitter, and our emitter map insert emitter get name and emitters size -1. Okay, so now we'll be able to add them in. We'll be able to keep track of them. That all looks good. I think if there's anything else we need to change in here. I think we're closing in. Nice. Okay, so in main here, we can no longer call initialize particle, right? We now need to create an emitter. So this, I think when you see why, you'll understand, you'll forgive me, but I've got a copy and paste here we're going to use. So the first thing, I have some decent smoke textures for particles, which I'm going to load. This smoke 01, smoke 2. I'm then going to create a particle emitter. You can see in here, I'm naming it smoke. I've got the number of particles that'll be emitted per minute. I've gone through and I've tried to break it all out. It is a lot of data here. Then I'm going to say add emitter temp enable emitter. Okay. Let's give this a shot. There's a little bit more code I want to write and a little more I want to talk about, but let's see if this is working before I jump the gun on that. Wonder, was I smart enough to? Looks good. I also need to in here, because we're changing the color, we should also say, so if a color change happens, we'll also. Come on, compiler. I believe in you. Something went wrong. Render. Oh, right. So the issue now is before, when we would start to render, immediately we would have particles, where now we don't necessarily have particles at the beginning, right? So I'm going to say if m particles empty is false, so our particles are still empty. We're not emitting. Oh, I forgot to tie in updating our emitters. So in our particle system now, because our particle system is responsible for all of the particle data, it's also responsible for the emitters. Emitters size. So add particles. So we'll loop through all of our emitters, calling update, which, if you remember, will return a vector of particles depending on how many are actually being made. Use the assist here. So we got one too many. Okay. Look at that. Some crazy rotations, but we have some particles coming up. Okay, so a couple things I want to do here before we call it. We're close. All right, I might do a little bit of messing around with these values to get some nicer particles, but there's one more thing I want to do here. So I want to just add a little bit of input control so we can test out the pausing and we can test out doing one-time emits. So I'm going to add this key callback function. So if escape is pressed, we quit. If left shift is pressed, we toggle the emitter. And if space is pressed, we do a one-time emit. I'm doing this key callback setup because GLFW is not very good at discerning individual clicks otherwise with what we have right now here. So it has a tendency to just pick up multiple presses. So things will get flipped back and forth on and off. If I do that. So if I hit space, we get a bunch emitted. If I hit shift, these guys still keep moving, but no new ones are emitted until I turn it off again. Okay, so we're just finishing up now. A couple things I wanted to kind of talk about before finishing. Obviously, this is very exciting. It's a huge improvement from what we had before. So much to do, though, still. Obviously, it would be nice to have lifespans to the particles. Right now, we're still limited by that 200 index. If I let this run for too long, for 2 minutes, we'll run out of space in our arrays and we'll have some problems. And two kind of interesting things to talk about before we finish off here. We have all of this data, right? We're kind of growing into the point where this is becoming more like an application rather than just a demo, right? So this would be somewhere where if you could serialize and deserialize data, that would be really helpful. In my game, I use Lua for everything. So I wonder if I can pull up some particle emitters. So you can see my particle emitters, exact type data, exactly the same, but I just store it in here so I don't have to have this in code, right? And the great thing with, if you have it in a separate file, you don't have to rebuild the game or the executable every single time you want to change something, which is awesome. The other thing I'll mention, which at some point, depending on how much this project grows, it would be nice to use something like DRMGUI to let us actually affect these changes on the fly, right? So I copy and pasted all of that hard-coded data. Using something like DRMGUI, you can quickly mock up a UI and you can change all of those values. So you could create new emitters on the fly, do it all in your engine, and hit save and serialize it out, which would be great to have. So things to think about. Maybe we'll bring it in soon. I think right now we've got some actual functionality to work on still, but still really exciting. With that, that'll do us for today. That's our longest video ever. Thanks so much for watching, guys. I really appreciate it. Have a great day. Make sure to stay tuned in, subscribe, like, fave, all of that. And I'll be back soon with another video. In the meantime, thank you all so much.